Haven't made a video in a while. I've had several people asking about combination circuits and have questions, so this is what we're going to do. It's very basic circuit. If you don't understand series circuits, you need to review the other videos. If you don't understand how we get resistance in a parallel circuit, you definitely need to watch the other videos to understand that, because we're going to be swapping back and forth. Other than that, I'm going to go ahead and orient you now to the circuit and how to get things set up. Combination circuit, our voltage, AC voltage at 120 volts, and it is going through resistor 1 at 30 ohms, and then we come to the parallel part of the circuit. R2 is at 10 ohms, R3 is at 30 ohms, and R4 is at 40 ohms, and then the power or the voltage comes back to its point of origin, which is the 120 volt AC circuit. Okay? This matrix right here is going to be paramount to you being able to keep track of all these numbers that you're getting ready to do. Okay, we have ET, which is our voltage total, our current total, our resistance total, and our power total. We have resistor 1, which is here. Resistor 1 voltage, resistor 1 current, resistor 1 resistance, and resistor 1 power. Now we have the next one in line is the combination, or the representative resistor for the 2, 3, and 4 that are in parallel. This number here is going to be the circuit total for this part of the circuit itself. Okay? Then E2 is the individual voltage going to resistor 2, current 2, resistor 2, and power 2. The voltage that'll be at resistor 3, current at resistor 3, the resistance at 3, and the power at 3, and voltage, current, resistance, and power at 4. Okay? So the first thing that you need to do when you come across a combination circuit is you have to find the parallel circuits. Okay? And when I say that, you have to find where those are, and there may be more. This is a very basic circuit, but you have to convert all of those parallel circuits into a series circuit representative resistor before you can do anything else. If you don't do that, it will not come out. So when you use parallel rules for the resistance, which is 1 over R2 plus 1 over R3 plus 1 over R4. You may hear this as reciprocal, which is basically you're just dividing the resistance of 2, which is 10 ohms. You're going to take 1 and divide that by 10. And then you're going to take 1 and divide it by 30 down here at resistor 3, and then you're going to take 1 and divide it by 40. And you'll add all of those up, and then you'll take that sum and you'll divide 1 by that again. Now, some of you have calculators, like this one here as an example. This symbol right here will give you the reciprocal, and you can do that. That's another, I think I have a video. If I don't, I'll put one out. Okay. So in the basic terms, we're going to figure out this representative resistor here. That number is going to go into this point right here. And this part that I've got boxed in red is going to be the representative resistor to convert this parallel area into a series resistor, so we can add it to this R1, and now series circuit rules follow, and we're just adding this R30 to whatever this comes up to be, and that'll be our resistance total for this circuit. Okay? Once we do that, now we can start working out our top information up here. Okay? And this is where it says here, add the series and the parallel. So R2, 3, 4, that's this one here. R1, that one's here. This information here has to be converted to this. Okay? So this is try to make my videos shorter so you guys have enough time to kind of digest this and have time to watch it. And then I'll make the next part of this where we'll actually do the math.